to another session of our joint Central Texas Consultants Network and live member group, and with co-hosts a bunch of other groups. I'll let Kai describe them, hosting today's talk. The Central Texas Consultants Network is part of the big IEEE Central Texas section, which is an overall international group. We have lots of meetings and journals and conferences annually. So I am the chair of the Consultants Network, and we have other officers here, live and online. So I think that's about all I have to say. So I will pass it over to Kai.
Okay. So this is a meeting with, with us 6 out 5 co-hosts. They are Denver, Fort Worth, Houston, Kansas City, Lone Star, and Central Texas. So just a little housekeeping. Please turn off your audio and video. And if you haven't done that, add your username so we can count who you are, so we can count whether you are a guest or an IEEE member. And you can ask questions in the chat box, and speaker will answer later. So after the during the Q&A session, then please turn on your video, audio to ask questions. Now, these are our team in Austin, and I want to go through real fast. Okay. So that's our plan. Probably seen them before. Those are our objectives for the year. And a little bit forecast. Next month, we'll talk about semiconductor golden year. It's about 30 years from the 70s to the 90s, when the industry really start to grow and then enable what we have today. Then in September, we're going to talk about industrial IoT. And next to tonight's speaker, probably you already read that, and Dr. Doug Matzke, and he's a retired engineer and also entrepreneur. He's doing a startup, and you already read his style. He's going to repeat that maybe a little bit later. And we're going to talk about the topic, soil science. So I'll turn my thing off and turn on the other.
Welcome to this month's meeting. I'm an engineer, but I'm working with a brand new company, and it's based on work I did for my book called Source Science Technology. And it's technology, just like electrical engineering is. So I'm going to talk to you about what that means. So for people who maybe know me, know that I go by the moniker Quantum Doug because I like everything quantum. So I was chairman for a conference in 92 and 94. So this is a history, and I've been programming for 55 years. In fact, I'm an IEEE life member. And so I'm an engineer and do a lot of software. And so I wrote a whole bunch of papers. I have a PhD in quantum computing from 20 years ago already. And the quantum computing is of using geometric algebra. So I'm interested in quantum computing, and from a topological perspective, which is the same kind of way that, relativity occurred. They were trying to look at, gravity from a spatial perspective. So I've been doing other research in that area, and so I'm going to show some of that. I've gotten grants, but the biggest thing is that I've been working on lately is this book I released a year and a half ago called Source Science. And my co-author is a guy named William Tillier. He's famous, but he's deceased now, so I'm gonna miss him. And I'm also I'm quite retired in consulting, but I started a new company as my retirement project because I don't play golf, So Coherent Spaces.life is the name of the company. So, could you imagine what it would be like if you were a budding scientist or an engineer back before electricity and magnetism concepts and components and equipment were even commonplace? That's the kind of frontier engineering that's happening now in the quantum computing and AI development. And so what I'm working on is related to that.
You can put stuff on top.
So I'm going to use examples of source science technology and how it relates to this new development I'm working on. And so just be aware that this is a burgeoning field. It's like a frontier science kind of area. And so, let's define what we mean by source science. So this is my term, source science. And, the key is that you start with information is physical, and this is just a comment that John Wheeler, that Ralph Landauer actually said. And so then I don't have to switch screens here, if you would, please. So information is physical and it's not just mathematical. And this relates to Ralph Landauer's work. And this is in the beginning of my book, by the way. I do have books here for those who are physically here, but you can get them online in Amazon, the deeprealitybook.com website also. But the point is that this is information is physical. So you have to say, you can't just ignore physics information from a physics perspective because it affects entropy. Okay. So once you have that, you say, okay, then what are you going to do with that? Okay. Well, reality is really hyperdimensional. It's not just 3 dimensions plus 1 time. And I'm going to be focusing about that, talking about that today in this discussion. So what does that mean? Well, you have bits, but then you have qubits and you have e-bits. But these are bits and qubits and e-bits that are in a mathematical framework that engineers aren't used to using. It's usually called Hilbert spaces. And that's what I did for my PhD, is a different kind of mathematics to describe the same thing. Okay. And so we're going to show another slide about that later. And, and it means that because of this difference is that quantum computing is fundamentally different than classical computer. And 25 years ago, Shor's algorithm was invented that showed you can do something with a quantum computer you can't do with a classical computer. And that's Shor's algorithm. So this was a big turning point in the nature. So if you believe that the world is really universe is really hyperdimensional, and you can build something like Shor's algorithm, you can actually build quantum computers, it has to do with a fundamental change in the way you think about the universe. Okay, so don't think about it as classical spacetime, not even a relativistic spacetime. No, it's a quantum spacetime, and we'll talk about what I mean by that. Okay, so then once you realize that, you realize there's all kinds of behaviors in the brain. Everybody's trying to say, oh, the brain is a classical computer, and we can therefore create an artificial intelligence brain that does the same thing as our brain. I say hogwash to that, because the quantum things are not in the brain. Thoughts are quantum things, not in the brain, and there's a bunch of reasons for that, and I'll talk about that. And so these information things like intention can affect the physical world. And we're going to talk about what I mean from an engineer's perspective of what that means. Okay. So and this solves some of the problems that we can't solve if you just ignore this research. Okay. So I say quantum mechanics is the dreams that stuff is made of. I mean, obviously you would find this slogan on a t-shirt, but I happen to like it. So I put it up here as well. So here's a little example of my favorite cartoon from Dilbert. It says, I created a simulation world that is made entirely of software. And I programmed all the people in the simulation to think they're real people with free will. And the little dog says, are they sentient beings? Well, they think they are. What if they discovered their true nature? I programmed their limits into their physics so they could never observe the walls of the reality. For example, they can't get to the edge of the universe because they exceed the speed of light. And they can't find out what they're made of because probability at the quantum level. And the funny joke about the last one is, wouldn't those limits tip off the smart ones? No, I coded them not to trust people, smart people. Okay. So what's so funny about this cartoon is he's connecting in in 8 slides here, in 8 panels, that humans, you could simulate humans and all of physics in software on a computer on his laptop. Well, that's really absurd, because turns out, Richard Feynman says, nature isn't classical, damn it. And if you want to make a simulation of nature, you'd better make it a quantum mechanical. And by golly, it's a wonderful problem because it doesn't look so easy. But somehow the universe did that. Okay. And so, I always say nature isn't classical, damn it. It's quantum mechanical. And that's based on the 3 premises that I already talked about in the source science premises. Okay. So what you have is everything is it from bit. This is Tiller, William Tiller did this here at UT, and he said it from bits. So even black holes are made from bits. Okay. So the quantum infrastructure is required to efficiently simulate a quantum universe. And I believe that the universe has a quantum simulator made of bits. That is the basis for that. And so, but why do I say that, you know, he's talking about, oh, he's simulating people in his computer. But I'm saying he doesn't if he's not using a quantum simulation. And the reason for that is that meaning is essential to science. And you go, wait a minute, meaning is essential to science? No, not if you're a classical worldview. You don't think of meaning as important, right? You say, well, we know this stuff, but no, meaning is required to understand concepts. It's for designing experiments, for building components and equipment, for interpreting results, defining potential inconsistencies in theory and practice, to educate and communicate. We don't have any general version of meaning that we use for general AI or anything like that. Meaning starts in the mind and it's projected upon our environment. And so one of the reasons I'm interested in source science is that meaning is part of the fundamental difference between humans and what AI and classical computers are. So I say it's real intelligence. It goes beyond information and space-time. And that's because AI has failed in general learning machines. There's no meaning in them. You know, they might recognize these patterns, but they don't know what that move means in chess. They do know that if you see this pattern, you can make that chess move. They don't know what it means. If they see a chair, they recognize a chair, but they don't know what it means. So those are all things about meaning, okay? Hyperdimensional math turns out gives you properties that are not possible in 3D math. That happens to be true with quantum mechanics, but it also happens to be true, and I'll show a slide here in a minute, about what's called correlations, okay? And it's a way that you can get properties out of hyperdimensional math that can't be possible in lower dimensional math, okay? And so this says that there's actually a hyperdimensional space that's beyond the simulation. In other words, the simulation is running on something, but you can't see the simulator because you're inside the simulation. And what's interesting is about that, if you're the whole universe running on top of a simulator, it's a space-like simulator because you have to simulate space-like stuff. So this makes this connectivity for entanglement, and it's space-like. And for anybody who's a scientist, space-like means it's non-local, it's outside the light cone. So you can't simulate it with traditional time, light, or energy, because those are inside the light cone, and space-like is outside the light cone. So it turns out quantum entanglement is outside the light cone. Okay, so I'm going to talk to you, I'm going to sort of like build you up about how I thought about this. By the way, all of this is in my book, Deep Reality. So I'm going to talk about quantum spaces, okay? You can take a single bit and you can represent it mathematically in a geometric algebra like I did for my dissertation, and you get this it's a mathematical representation that is topological as well. So it's not just Boolean algebra, it's geometric algebra. Okay, and so what you can have is you can have two dimensions, and you can think of them as vectors, and these are mutually exclusive in that if you sum the two, they cancel to zero. Anytime you have zero in this math, it means cannot exist, does not exist, which means you can't have a single bit in two states, both 0 and 1 at the same time. Okay, that's mutual exclusion. But as soon as you get to a qubit, you actually have two of those bit vectors, but they're 90 degrees apart, or they're orthogonal. Okay, and when you do that, you actually can create these higher graded things called bivectors, which is the outer product of the two vectors. Okay, it's a third thing, and it looks like this little graphic on the bottom. It looks like this little bivector on the bottom, and it's orthogonal to either A or B. So you can see that you can build a qubit build a 3D dimensional space as a qubit, and it looks just like the Hilbert space. And that's what I did for my dissertation, to show that that's quantum computing. And with a qubit, you can actually show a whole bunch of things, including you can do qubits, you can do e-bits, but you can also show that particles that are unitary and idempotent show up in even G2. So part of the work I've done is show that you can bootstrap the standard model using this view of the universe, which is important. So then you go to a qubit, and a qubit is the first thing that's big enough to represent a three-dimensional space. And it has 3 dimensions, A, B, and C, which means you can represent a volume, but it also allows you to represent quaternions. And everybody knows in physics that quaternions are important because you can represent 3-dimensional rotations. Okay, but you can also, once you have a 3D space, you have enough state space size to represent photons, gluons, quarks, mesons, electrons, and neutrinos. Okay, and so you have more neutrinos in 3 dimensions, but they're essentially 2-dimensional versions of them in themselves. Okay, So finally, you get to an E-bit. This is what an E-bit looks like. It's 4 dimensions, but it's not just one more of the 3-dimensional space. It's 2 2-dimensional spaces. And so what you form is these, what we refer to as bivectors. By the way, this looks just like the form that you would in Hilbert space, except this is in geometric algebra, and it means the same thing, except that now we have the Bell and magic operator is written like this. These states are entangled and they're inseparable, which means you can't factor them. And this is a slightly different prediction than the Hilbert space math does. And we think this is fundamentally important because if everything is entangled, anything above 4 dimensions can be entangled because you can't, it's like a knot. If you have only 2-dimensional space, you can't build a knot. You have to have at least 3 dimensions. Well, you can't build an entangled state, an E-bit, unless you have 4 dimensions. It's for the same reason, is you don't have enough room in the space to represent it. Okay, so this is the basis for what I say, it's hyperdimensional. That's exactly what I mean, is this is the bootstrapping up from bits up through to support quantum computing and also all of the standard model stuff. So this is what I've been doing over the last 20 years, and on all the standard model stuff has been over the last 10 years, okay? So there's a lot, you know, again, these hyperdimensional spaces are formed from an infinite set of bit vectors. So you go, oh, well, where are those infinite set of bit vectors? Well, they're not in 3-dimensional space. This is all assuming that these bits are just mathematical bits and they're not in 3 space or 3 space plus time. So time and space emerges out of this in your simulation. So that's important to realize that, okay? So you go, well, why are you telling us all this, Doug? Well, most people think, oh, well, here's the hierarchy. You know, we have people, we have atoms, we have quarks on the bottom, but people don't realize below electrons and quarks, we have the Planck scale. And then at the very bottom, we have quantum foam, just to see how big this stuff is, how far apart they are. And I believe everything I'm just talking about here is below the blue line, which means it's below quantum foam. It's before space and time exists. And since space and time doesn't exist, then you don't have any space-time metrics either. And so you have just this pool of bits that are orthogonal. And if you know anything about, if you take a 4-dimensional state, you can't represent it in a 3-dimensional space because you get anisotropic behaviors, okay? Same thing, you can't put a three-dimensional space in 2 dimensions. All you get is the shadow of it, right? And so this is important to realize. If you have an infinite dimensional space, that is the basis, I call it protophysics or bit physics, and it's the basis for the hyperspace that is bits and qubits. It's also the basis for E-bits. And then that from that, matter, energy, space, and time all exists on top of that. So here's another slide that looked like that. So it's it from bit. This is quantum space like it from bit, okay? You start out with all of these stuff down here at the bottom. They're just random bits. Every single bit is orthogonal to every single bit. So if you have a million dimensions, you have a million dimensional orthogonal space. And anybody who's an engineer would hurt their mind, and other people who are not technical wouldn't even figure out what I'm talking about. But it hurts my mind for the first 20 years I worked on it too. But realize when I say that they're orthogonal, and this means something mathematically very important. You can't compress those hyperdimensional spaces into like what they say, oh, it's a hologram and we're gonna map it into a 2D world. No, you can't do that. Because again, you get anisotropic behavior. You can't simulate E-bits in a hologram, okay? So what happens is then these things build up. All these little blue things are complex structures. They're E-bits, they're the Higgs bosons. I believe they're also thoughts. And then finally you get to space-time and you get the quantum foam. And then on top of that, you get space and time from the quaternions. And by the way, you can have 3-dimensional space show up in 3 dimensions. That's called quaternions. But you can also represent quaternions in a 4-dimensional space. We call those tau quaternions. And you can also simulate a 3-dimensional space in a 5-dimensional space. And we call those tauquinions. And so already I'm showing you how you can simulate space if you have a higher numbered dimensional space as your infrastructure, okay? And by the way, in 2D and 3D, even space itself is entangled. And most people don't realize that. So which means that all the Higgs boson and all the stuff we see about entanglement comes out of space itself being entangled, not just E-bits. So you've got non-locality built in to the quantum foam from the beginning, okay? So now you can have the simulation world like this, where you have 3D universe simulating on top of this hyperdimensional, infinite dimensional backplane, you know, and this is what it looks like if you were to try to represent it graphically, and you get all of the standard model stuff out of this. And eventually you get to what I call correlatives, and I'm going to have one slide about this. If you're, you know, source science is about thoughts and meaning and law of attraction. Well, you can't have law of attraction unless you have meaning. And so where does the vortex come from law of attraction, for people who know what I'm talking about on that? But basically think that if you were to randomly close your eyes and start throwing at a dartboard, the highly unlikely that you would get very many darts in the middle of the dartboard. That's highly unlikely. But if you did that, essentially, it would be information important, and that's an equivalent energy. In other words, it's highly unlikely that all the darts would be in the middle of the dartboard. From a probabilistic and from an entropy perspective, that's highly unlikely. And so if you opened your eyes and saw all the darts in the middle of the board, you would go, that something special happened there statistically, okay? And that's what correlatives are. It says every thought that is consistently repeated over and over and over again forms like this little vortex of thought, and it's like all of the things showing up the dartboard in the center. And it's highly unlikely that occurs because all the points in a random high dimensional space are infinitely far apart from each other. They're all at what's called standard distance. And so I'm going to show what that means. This is a content reducible memory. If you take 2 points and you put it in 3-dimensional space, hey, everybody can do that. But if you put a point P in a 100-dimensional space, that's hard to imagine that. Now pick a second point and you build all these points, and you see that the distribution of the points, their distance from each other, keeps increasing with the number of dimensions, but because everyone is random, each of the sides of this dimensional space like cancels each other out. So the standard deviation is the same no matter what dimension you have. So this represents sort of like a speed of light kind of metric that says for a 100-dimensional space or a 1,000-dimensional space, you can compute exactly the standard distance, and you can say, this is randomness. And anything less than that is considered the bullseyes. And so there's where the vortex comes from. Okay, so that's where meaning comes from, is the vortex. Okay, so I'm using it, trying to use it in very general terms, but there's strong mathematics for all of this. And we created this little icon here to show what this all means. But this is neural computing. If you take a bunch of bits, hundreds or thousands or millions of them, they form a space that has these properties. And in fact, the guy who invented Palm Pilot went and founded a neural computing company, and he basically is using a similar kind of math to this. And he says, if you're not using this class of mathematics, essentially you can't do AI because you're not using the mathematical properties of this space, okay? And you can't simulate it in lower dimensional space because it doesn't behave. Having the space with those dimensions in it versus simulating that space with those dimensions in it are two different things. Your matrix sizes grow too big and you can't simulate it. And so you can't simulate it using matrix math anymore because it just blows up. It's too big in any conventional computer perspective. So just be aware that this is all related to that first Hilbert slide, how thoughts and how they build it from a simulation infrastructure and how the universe is built from the same thing. And that's why I call this source science. So you get the standard distance and the standard radius, and you find out that this becomes sort of the constant that you use to say, is this close to something or not? And you can actually, it's an information content. So you have an information content. So this is what I call the mathematics of law of attraction. And it's also the mathematics for meaning. And it's the only place in physics where things that are near each other are like each other can be represented. Because any kind of electromagnetics, there's no any kind of other law of physics that says, oh, these two things are near each other, so there's a law of attraction mechanism. No, there isn't. So it shows up in the mathematical world and you go, oh, Doug, this can't be true. And in fact, I've talked to mathematicians about this and they go, this isn't true, you're making this up. And you can do it in a spreadsheet in about 10 minutes. So you can prove this to yourself. You know, so even mathematicians, this is so counterintuitive that mathematicians don't believe this either. But once you realize, oh, we have an infinite dimensional space and you have points in this n-dimensional space, most things are very far away from each other, but things that are near each other, those are special and those are the meaning points. Like the chair is a point in the hyperdimensional space, and a rocking chair is near that place in the high dimensional space because it's similar. It has similar properties and overlap. And so it's built up out of all these attributes, smaller attributes, form this bigger, higher dimensional vector that is that is the meaning vector for these thoughts, okay? And so these dimensions aren't in the physical world, they're in a quantum space, okay? Which goes back to the original source science number 3 point I put up there. So what I say is mind is the ultimate instrument. Why do I say that? Well, first of all, we have meaning, but we also can know a subject without any traditional learning. Like if any of you engineers in there have ever studied some math and the math sort of talked to you and you figured out, oh, I can figure this out on my own, but it's like you're interacting with the math and the math is teaching you how to do it. Well, I've known people who say that they've been, you know, you've all seen The Matrix, right? Where the movie says, I've downloaded how to fly a helicopter, right? As though you can do that in the brain. Well, it turns out I've had this lady says, I was being downloaded mathematical formulas into my brain. And I said, no, go somewhere else. That's not for me. But you can essentially call into that. And in fact, I think some of the famous Indian mathematicians do that. They tapped into what we call the archetype of mathematics that exists independent of humans, and you can tap into it to find the meaning of the math. And so how do you think these people got the insight to do that? They worked hard? No, they got help. They got help from these archetypes of mathematics. So here's an example of that. And I'm saying this to you because this is information science that doesn't make sense from a classical perspective. So I'm trying to give you sort of an engineer's perspective of why I'm saying this, okay? Well, you can get intuition during your dreams or knowing about technology and interventions. One guy at a company that I'm not going to say his name, is he was a vice president and he had all these inventions and he was looking into the future to get the inventions. And he had more inventions than anybody else at this company. So he was cheating, you know. And so if it's possible to do that, I think a lot of people are doing that. They're just not saying they're doing that. So, you know, our team is kind of using some of those same techniques to figure out, well, what should we be doing? Okay. So we're downloading mathematical understanding. What if you could actually see the electromagnetic power flow around a circuit? Or what if you could actually look at the energy wells on a semiconductor? No encryption key would be secure if you could do that. And I know people who can do this, okay? You can also go look at quark-like states. So the point is that as an engineer, I'm going, if these things are possible, and I know people who can do this, that you can see the biofields around plants and people. And I'll show you some examples here in a minute. And some people can influence quantum states, even though they're in you know, Dean Radin did this experiment. And remote viewing, we're going to actually do a remote viewing experiment here. I've done this with other engineers and they're pretty good at it because they're used to visualizing this stuff. So we're going to talk about that in a minute here, okay? So you say, well, where are all these information? You know, and some people say, well, there's a thing called Akashic records. Well, if there is a thing like Akashic records, well, it's an information source of some kind. And as an engineer, I'm curious about that, okay? So for example, have anybody seen this Veritasium YouTube video? It says how electricity actually flows. It's not flowing due to electromagnetics on the current, the actual electrons flowing through, because the electrons never actually get to the other end, but it's using the electromagnetic field around the wire. And I know somebody who can see these flows around the power around the wires, okay? It's important if you're trying to lay out a circuit. And so what happens is our models and instruments limit how we view the world. Is it possible to directly influence this, directly experience this power flow? And I say, yes, it is. Okay, here's an example. Human can see biofields. A friend of mine who's a healer, this is the image she draws of humans, okay? Likewise, from 100 years ago, there's a thing called Anus. And Anus was essentially, before quarks were even envisioned, they were drawing images that looked like quark theory by just essentially remote viewing down at the atomic level. So what I'm going to do is I have this little experiment here set up. And it's okay if you're remote. You don't have to be here because I have box A, B, and C. And I'm just going to set them up here, A, B, and C in front of me. And here's the box, pictures of the box right here as well in the slides. And so all you have to do is during this talk, just quiet your mind pick one of those, just figure out which one you're going to pick, and then draw whatever images come to your mind when you do this. And like I said, I've done this with other engineering communities, and they're surprised at how good they are at this, okay? So I'm just using this as a demonstration that says, statistically, this should not be possible to do at all. And anytime you have an unusual statistics, it means that there's a mechanism there that we don't understand. So I'm using this as an example of that. So if, get your pad and paper out, and as you keep going through here, just draw whatever. Remember, this isn't going to label it. You might see these triangles. I don't have an Eiffel Tower here, but I'm just using this example. Somebody might see a picture of an Eiffel Tower, and they see these lines going vertical and horizontal. They might not have to label it Eiffel Tower, but they might draw all the elements of the Eiffel Tower without actually knowing it's the Eiffel Tower as a label, okay? So there's 3 boxes in here, and I'm going to reveal what these are both in the room here, but also in the slides in a minute, okay? So believe me when I say you can do this, and anybody can do this. And the more you do this, the better you get at it. So here's an example where intention can affect the quantum states. He had a twin slit experiment, a double slit experiment, and you could use intention to either influence it or not influence, and you could actually change the quantum states inside a sealed box doing an automated double slit experiment. And to me, this guy should get a Nobel Prize for this experiment because it's the first time it was really well controlled where you could do this. So, and you go, well, how is that possible? Quantum states aren't even electromagnetic. How is it possible to do that? Well, I say that the mind is these quantum states is the same, and it's what I saw about source science. Source science is common between mind and thoughts and these bits and how all that's related, okay? And so as scientists, as engineers, you should be curious about this. And if you're not, okay, continue on with the way your life is, but this is exciting to me. So my co-author did this gas discharge tube where he was doing the same thing, where he was showing you could affect the gas discharge rate. You'd have a gas discharge thing near ready to discharge, and then somebody would focus in on it, and then it would have a cascade effect. So essentially you were changing the tunneling current through your ball. So these are all quantum mechanical properties, okay? And these are all no electromagnetic effects could be possibly doing this because they were all in shielded containers or remote containers, okay? So I'm gonna skip that one because it's about time. So the point is you can say, okay, Doug, this seems pretty weird. And I'm saying, yeah, but you can look at it from an engineering perspective. You can find that all these phenomena fall under, they either have an information, space, time, or energy perspective on that. And I have other talks where I've gone through these more specifically, but this audience, I'm just showing you that it's possible to think about this phenomena, like the remote viewing experiment that we're doing here right now, about thinking about it says, okay, how is that possible? So, and I call these phenomena the problems, the real hard problem of real intelligence. And everybody talks about consciousness has the hard problems of consciousness, but I'm saying, no, this is the real hard problems of real intelligence, okay? So let's talk about this quantum infrastructure here and the quantum randomness. Well, it turns out my new company is working on this device here. We call it the WISH unit, World Integrity Space Harmonizer is the acronym, WISH is the acronym for it. But basically it takes the randomness of the quantum foam and it turns it into what I would call these ordered spaces. There's a higher dimensional version of crystals, if you want to think about them. And there's a name for these patterns, which every time I try to reach out for it, I block on the name for it. The fractal sets, these are fractals, okay? And fractals are like snowflakes in a higher dimensional space, and they're repeating. So, and you can think of them as a higher dimensional version of a crystal, of a snowflake or a crystal, okay? So what if you could do this? And this is, I'm introducing you that the way we're doing this is we're actually using quantum resonance, which is at a higher dimensional than our 3D space, essentially, and we're making these spaces more coherent and ordered, and this supports thoughts being more orderly as well, as it turns out. Okay, so here's the device. I'm just to give you a little bit more about it, but that was sort of the justification of what we're doing. And here is, so I actually have a device right here, and I'm going to turn it on. And for those who are in the room, great. Those who are out of the room, also okay. So I've turned this on, and if you are there are people who can see the auras like around these people. And anytime now I'm getting familiar enough with this, so anytime I turn it on, I feel it all over in my arms, okay? And there are people who this helps, and I'm going to tell you the markets that we're going to apply this for. And this is a technology we're going to do. It's called these wish units. And even the logo itself is being energized by this unit. And so the logo itself has an effect on people. For example, my sister put the logo on her screen and her dog started going crazy. So we just print out the logo and say, put it under your dog's bed, and you can have an effect on the animals because you're changing the order of the space that you're in. So we're calling it coherent spaces. And you go, how do you even know how that's possible? Because the guy who invented this did it for 25 years, and he's been looking at these behaviors for 25 years, and now it's time to bring it so other people can get access to it. So that's what we're doing. So this is a unique, since this is designed with electrical requirements, but also this, what I would call source science awareness, this a view of energy flow. He's had other people try to build devices like this, and they just had electrical engineers going, oh, I'll just lay this out in an efficient way, and it didn't work. It didn't have the same effect as this one does. Okay, that's because they didn't think, oh, just because it's electrical, then it's equivalent. Nope, not in this time. So this is the difference between electrical engineering and source science engineering. Okay, and so a lot of care went into the layout of this so that it didn't disrupt the flow. And in fact, this device, I have it on right now. It forms this vortex coming out the top, and then it cascades around the room, and it actually changes the coherence of the room to make it more high dimensional. And you go, that sounds pretty far-fetched, Doug. What is it going to do? Well, it's this quantum resonance that we think, and it makes them more coherent and more orderly, like I was showing you before. And it turns out these negative thoughts are more chaotic, and they're lower energy and lower dimensional. They kind of disappear because they just like fall out of it. They don't be supported in that space anymore. And some people, you know, if they are really strongly negative, they don't like to be in the room with it either. Just to give you a sense of that it's not only, but they don't like it for that reason, you know. So I'm just giving you a sense that that's, and so what you can think about this is a communications device that supports your higher self and intuition. Our inventor calls it the new best friend, because it's helping you connect with who you really are, your higher self, which means intuition. Most engineers are pretty introverted, I think, because they're in their own thoughts, right? Well, this will help you connect with your higher self. You'll be even more intuitive and more thoughtful and more aware of where those insights are coming from, okay? So what is our target market for this? Well, it's personal and it's professional. Autistic kids love this. Okay, why? One of the people on our founders team here is one person who's been working with autistic kids for 20 years, 30 years. And her name's Susie, and she has this whole team of people who have been working with autistic kids in a very different way than very many other people. These autistic kids, when they have this on, all of a sudden their higher self, they're really intelligent, they're savants, they're intellectual beings, they're very smart. They can't interact with their physical body very well. You turn this on and it makes this connection better, and they calm down, and all the negative thoughts that are in the world sort of like are shielded from them. And now all of a sudden they're happy and they're easier going. And in one of the pilot studies we did with my co-author, they did an earlier version of this device, not as good as this device is. An earlier version of this device, one of the kids who started the study is nonverbal, and he went verbal during the study. So any parent who finds out that their kid can be going verbal by having one of these devices to support their kid, their autistic kid, that's an important idea. So we think that we're getting feedback we're expecting that those kinds of things may happen, okay? But we think it would be going yoga studios, massage therapists, elderly care, chiropractic kids, chiropractic groups, and elderly care, homes and offices. This is the market we think that's for this. So, another example of the result was this one autistic kid was really not sleeping through the night at all. And they bought one of these and turned it on. And after a couple of days, he slept through the night for the first time ever, all the way through the night. Again, a miracle for the parents who are involved with it. So I want to mention to you that this is not a medical device. It's more of a self-help meditation device. And we don't make any medical claims. These aren't medical claims. These are behavioral results that these people are reporting as a result of using this device, okay? So we think that this will help people but we're not making any, it's not going to cure anything, but it may assist the behavior of their kids so that they're less frustrated with their life and interacting with their brain. So Einstein says, and I only found out this re-saying a couple days ago, and I loved it so much I included it in here. It says, Einstein says, there's only two ways to live your life. One is as though nothing is a miracle, and the other is though everything is a miracle. And when you start looking at the source science technology, you're looking at the latter. And if you're a classical physicist perspective and you think AI and robotic intelligence, that's the first one. There's nothing miracle about that. The more you learn about science, the more miracle of everything that you find out about it. But the more you find out about this area, you realize everything is miraculous. So anyhow, I love that saying. It's a lot of these sayings I have in here are fun. So I don't know what our time scale is here, but I'm almost to the done with my slides, so we'll have more time for questions. So you start out with this pre-quantum proto-bit space-like reality, and then you form our reality out of it, including everything that's in our universe, big bangs and black holes and supernovas and thought. And if you have a quantum simulation environment that's powerful enough to simulate our universe in, it's probably powerful enough to do correlative stuff in thoughts and intentions and attentions. So we think that this is all related. And so we can make testable predictions based on these models. And my co-author, that was now, like I said, deceased, he did experiments, he got funding and did experiments to prove that you could actually measure this stuff. And so I talk about that in my book, Deep Reality book. And so let's reveal the three boxes here, okay? So for those of you who are in the room, I'm going to open them up. In Kai, in fact, if you would do the honors. And then I'm going to reveal it to the audience here too. And it's basically the first one, push the little clip on it. Push it. Yeah. So if you've been, so here's the second one. That's the first one. Here's the second one. It's a harmonica in box B. And the third one is a red ribbon with a metal on it, which was from a little hang glide, not a hang glide, rope thing. Canopy adventures, So as you can see, these three boxes have completely different, what we would call modalities in them. If you describe some aspect of any one of these, you would find very little overlap with the other three. Well, that's how your mind works in these patterns, and people who are auditory would say, oh, that thing has music in it, the harmonica, okay? And so, and when we get to the question period, I'd like people, and by the way, when I did the experiment with a bunch of other engineers one time, and especially this one, the first one, this one here, the first one is a rotating pen that has a little spinning light on it. They drew, 3 or 4 of them drew the exact picture of that thing, even with the lights on. And these are engineers that were across the country when they did it. So the fact that it's possible to do that, like I said, it's a new field of information science that most people are ignoring because they're too busy working on quantum computing and AI. I think this is a combination of quantum computing and AI called real intelligence that's more important than any of those two other things combined. Okay, and so we have this wish unit now, and so if you want, we're gonna take questions and answer here, and I want your feedback on the reveal of the boxes and any sensations you had about the wish unit. This wish unit has a blue light coming out of the top that we see is on here right now. And so thanks for your time and attention. Again, there's our box here and the book, and my book, and that's the end of the presentation. So if you guys, because it got disconnected. Okay, so if you want to, however you want to do this to open it for questions. Yes. If you want to manage the questions.
Hello. Please ask a question. You can type in or you just
or comments. Comments.
Yeah, about the remote viewing stuff. So actually, I'm thinking about the
Uh-huh.
Turns out.
Mm-hmm. Yeah, exactly.
So yeah, some other reactions like this or.
No, these are the three questions I had. But harmonica, you know, they have reeds in them. So if you don't know at what level you're supposed to
Okay, okay, that's.
so you can't just now just count it. You might not be able to name it.
We can't hear anything online. You're too far from the mic.
Getting closer to the mic again here. So, so anybody else have any comments that they want to, you know, table their mic and either comment about what they heard? Go ahead.
Yeah, actually, I have a question. 51, you're describing some wave or.
It's not producing electromagnetic.
Okay.
It's creating a quantum resonance pressure changing. Quantum.
But I think that a lot of scientists think everything's a wave.
Well, it is a wave. Even quantum field theory is a wave.
Okay.
Everything is oscillating on field theory. So from an engineer's perspective, it's all frequency. But in the space of hyperdimensional space, there's no space or time. So you can't even talk about it for like string theory. You can't talk about frequencies.
We still can't hear a word you're saying.
Oh, really? I'm right in front of the mic here. So so can you hear me now? Is that better?
Yeah.
Okay, I'll be right in front of the mic here. How's that? I was off to the side just a little bit. So quantum, you know, quantum field theory is if you have quantum field theory or string theory even, there is no frequencies there either. There's just these modes of vibration for the strings. So that's more of what it is like. It's not even frequency, it's pre-frequency. And there's no wavelength either, so it's pre-wavelength. So it's hard for engineers to think about that. But it's what is the mechanism of a pattern? It's like a slinky going down. There's a pattern that produces the slinky pattern in time. So think of it as a little oscillator structure so that it provides resonance and oscillation inside space-time. And so the current thing, there's this new thing called the time crystal, and the time crystal is an example of that. It creates this repeating pattern in time, but even though there's just a static structure in the quantum area that does this. Okay, so anybody else have a question or comment? Is this anything that people expected from this talk, or is this completely like completely different than most people even ever thought about before? I mean, because this is an engineering community, right? And I've talked a little bit. So go ahead, make your comment.
Yeah, I want to ask a question on mind. How do you define mind?
Well, this mind is a point in each thought is a point in high dimensional space. And each point in high dimensional space you can think of as a vector in hyperdimensional space. And a thought is a set of these vectors in hyperdimensional space. And since they're all orthogonal, you can have any number of thoughts superimposed on top of each other. And the mind is literally the set of all possible thoughts that we have superimposed each other on top of a hyperdimensional space. And you go, Doug, how can you even talk about it that way? It turns out that our cell phone technology uses CDMA, code division multiple access, and sparse distributed coding, right? This notion that you have spread spectrum. Spread spectrum is doing exactly the same thing, but it's using exact codes, and this is using random codes, which are orthogonal. So if you can talk on your phone, then you can show that hyperdimensional math works for orthogonally keeping things away from each other. And that's how our cell phone works. Well, imagine if your mind was the same technology, but in the quantum domain. So our mind is a set of all possible thoughts that we have organized into a big set of hyperdimensional space vectors. And some of those form these wells that I was talking about, vortexes. And again, I've been thinking about this stuff for 20, 25 years, guys. And so one of my superpowers is that I can visualize this stuff. Okay, and most people haven't ever thought about it before, so they have no clue about how to visualize it. So again, go read my book, and maybe we'll get some insight about how I think about that, because that's 400 pages where I tried to describe that, about what that is. So did that answer your question?
Well, yeah, I have, well, it created another question. Is a polar coordinates, are you talking about polar coordinates versus Cartesian coordinates?
Well, remember, polar coordinates and Cartesian coordinates assume there's a space-time metric, but we're using the same math in a hyperdimensional bit space, so it talks about meaning. So the distance is how far apart something is based on their meaning, not how far apart it is in feet or inches. And so it doesn't have a metric. For example, what's the diameter? You can compute the circumference of a black hole, it's the event horizon. But what's the diameter of a black hole? Well, it turns out the inside of a black hole is a singularity, which means that space is totally contracted. So the diameter across the center of the black hole is 0, the length is 0. So anytime you have a hyperdimensional space, your intuition about how the space is formed is completely unintuitive to most people. And they say, well, there is a diameter to the black hole. No, there isn't. It's metric space. Its length is 0. Space is totally contracted. And in fact, the entire volume of the black hole is on its surface area. That's called the event horizon. That's the it from bit. Okay. If you throw a bit into a black hole, it's the smallest size of the thing that you can do. And the smallest thing that you can throw into a black hole shows up on its surface area as Planck's area on the side. And so everything is a bit bucket inside the black hole, and it's all on the surface area. There's no inside to a black hole. So just realize metrics have no meaning in a hyperdimensional space or a complete relativistic, a contraction like you do in a black hole scenarios.
Okay.
Does this make sense?
A little bit.
It may not have any meaning yet, but I'm giving you the real reason why it's hard to think about. So again.
Yeah, I've got intuition myself. So I was wondering what the heck happened to me for so many decades that I've lived.
Yeah, exactly.
And intuition doesn't have age to it, as far as I'm concerned. Yeah. Like some child can have an intuitive feelings and all that stuff. So you are right. I mean, yeah.
And a musician savant, they know how to do stuff that they were never taught. How do they do that? I think savants are really important because they show that a classical worldview of the brain doesn't work. Because how do these people have this knowledge where they have the same hardware as everybody else, but yet they're super smart? Okay, so we have to account for that, and I call that the savant is like in the extreme. That's called infinite intelligence. So if you don't have a model for infinite intelligence, then essentially that's our super consciousness and our unconscious. It's much smarter than we are because it's much bigger than we are. Essentially, our conscious mind is only a small tip of the iceberg compared projection of our bigger supermind, which essentially, if you were all knowing, you can't know it all at one time anyhow. But when you're looking to solve a problem, the knowing that you need to have for that problem shows up because you're asking. So the mind is about asking and remembering things you may not have ever learned before, but it's available to you. So this remote viewing, did anybody have any kind of results from the remote viewing experiments, or have any results from when I turn on the device? Have anybody have an experience they want to report? It's okay. People can be bashful. That's okay. But believe me when I tell you, yeah, go ahead.
Let me ask a third, not a question, just a comment.
Sure.
So you believe in positive thoughts versus negative thoughts?
Yeah, right.
Because positive thoughts and negative thoughts are opposing each other, basically.
Okay.
I say positive because you said negative, so that's the reason on your right.
Yeah. So I would say positive thoughts and negative thoughts. Most of the time, people associated that with emotion, like joy versus anger, right? So just realize that whatever, one of the strongest ways of encoding memories is including your emotional state in it. Okay. And again, I talk about it in the book as well. And just realize that your emotional state.
But wait, just 1 minute. What are good thoughts then versus
Yeah,
evil
that's
thoughts?
that's what I'm explaining.
You're coming. Okay.
Yeah,
You're
I'm coming to that. It's just,
okay.
I had to sort of
Okay.
set up the solution. Otherwise, you wouldn't
Okay.
understand what I was going to say.
Right. I understand.
So-
Right.
So
Okay.
if emotion is part of that encoding of your thoughts, then think of that all the thoughts that you have when you're joyful is like having your thoughts stored in the castle. And all the thoughts that you're encoding when you're angry are like having them stored in the gutter. And so what would you consider positive or negative labels for where the thoughts are in the gutter versus in the castle? And we, as a collective society, we would say the castle is the positive thoughts and the gutter is the negative thoughts, but it's the same representation for both. It's just that they're using emotion. So choose what emotional state you use to encode all your information in, all your thoughts in, and then you will have an easier time remembering those thoughts again if you're in that same state. So live in joy, and all your memories will be in joy too. And so hopefully that gave you some clue about where I'm coming from with that.
Yeah, but let me argue a little bit on this. I asked the question, good thoughts.
Yeah.
But good thoughts are different than the Judeo-Christian thoughts or Islamic thoughts, the Abrahamic religion's thoughts.
Okay.
And you know where I'm going with these thoughts.
Yeah, exactly. Well,
So
it's
do you?
it's for the,
It's
think of the good thoughts as the highest good for all involved.
Well, I think
Not
like
just,
that.
not
but-
just the highest good for you, but the highest good for all involved is a one way.
Well, that's a good definition. Yeah, I agree. Yeah, that part.
It's
yeah, good
it's
thoughts.
bigger than just the individual, right? So
Yeah, that's true. But how do you get a good thought individually? How can one get a good thought?
there's a whole bunch of techniques for doing that. Go read the law of attraction workshop literature, especially the ladder, the emotional ladder. Read about the emotional ladder and how you go from more heavy negative thoughts and up through more positive, neutral, and then joyous thoughts at the top. And just go read about that, and that'll give you some insight about how I think about it. And I think that's an effective lifestyle choice for people under law of attraction. So emotional ladder.
When I was much younger, I learned good thoughts were defined by one's conscience.
Yeah.
Do you buy that? One's conscience of a good thought?
Well,
I'm trying to be a philosopher, so.
Yes, I know, and it might be that this is the kind of thing that we don't have in an open session, that we have it with a beer.
Right, that's true. Yeah, it's a philosophy thing.
And by the way, who's speaking right now? I just wanted to make sure I knew who was speaking.
I'm Beram.
Okay, Baram. Okay,
Beram,
because it wasn't
yeah.
sure who was speaking because of the interface I'm looking at here. So
Yeah, that's all right. I understand. Thank you for your time. Yeah, thank
yeah,
you.
exactly. So like I said, I don't know where you are, but I'm in Austin, and this is the kind of thing that I like to go out, have a beer with, talk to people about. So.
Yeah, I'm in Austin as well, so that's okay.
Yeah. Okay.
Thank you. Yeah.
So any other feedback about the remote viewing experiment, or the 3 boxes, or the device? So if anyone has any comments, please feel free to do it. Otherwise, I think I'll turn it back over to Kai if nobody has any more questions or comments, and then we'll wrap up the meeting.
Talk about the book you have in the.
Well, I mean, it's available, deeprealitybook.com, or you can go into Amazon and yeah, deeprealitybook.com or Amazon. Deep Reality is the book. And again, essentially my book is my business plan for this company that I'm starting. And the company's really taken off really quickly because we haven't even got the web pages up yet, and we've sold 40 units of these already. And so my job as the engineer in the group is to build the next 200. So that's where I'm at. So my retirement plan. Good thing I don't play golf.
How do we get the PowerPoint slides, please?
They will release them And also they'll be on my quantumdoug.com website when we're done with this.
Thank you.
Okay, did you have any other questions? Those people who signed up for this, they'll get a email that says, here's where the video is from Kai. And I know that because I've gotten them before from him. And then I'll also make it available on my pages so that people who weren't on part of this original email chain will be able to find them. So. Okay, so Kai, did you have any closing words? Otherwise, or any other comments? Otherwise, I'll sign off.
Okay. Any other questions from this room?
Our invitation.
Can you stop over, use the mic? Or
Pass that mic, because the speaker right next to it.
turn the power on. He turned the power on.
Does that?
It's on.
I was just curious. I was just curious. I was. It's quite a figure out which one is the electron. Okay.
For those of you who don't know, this little yellow thing has a spinning top on the top. My granddaughter loves it.
I thought maybe it would be good.
So the question was, he imagined a spinning thing or electron, and then on top of that, again, it's a spinning.
All right. Well, is there any other questions? If not, then we'll close the session today. And
Thanks,
you
Kai.
for joining us. And Rand, nice to see you. How to see you on pages. All right. So let's give him a hand.
Thanks, everybody.
Yeah. So I'm closing the session. All right. So
Recording.
so wait for you can check our website. You can see the video link.